Right, so we're going to talk about the disk and washer methods here. So first we'll do the disk method. And so just starting with an equation y equals x squared, so parabola, we're going to bound a region in the first quadrant, and between that graph, the x-axis, and then the vertical line, x equals 3, so this little shaded region here. And just to keep things simple at the start, we're going to revolve around the x-axis. And so we set up what we call a representative rectangle, and it's always perpendicular to that axis of revolution. And so in this case, it's a vertical rectangle. That little thickness is that little dx, and then the height is just the x squared. And so when we revolve that rectangle around the x-axis, we get this nice little disk shape. And we want to make sure that no matter where we draw the rectangle in that region, we're going to basically get the same thing, and I think we will. We'll get a disk with radius of x squared, the height of that rectangle, and that little thickness of dx. And so how do I find the volume of a disk like this? Well, it's just the area of the circle, the base, times that little thickness. And so pi times radius squared times the thickness, and then I add it up over the whole interval, in this case going from 0 at the vertex up to 3, so integrate from 0 to 3. This would not be too hard of one to do by hand, because x squared is just x to the fourth. But you could also definitely do this on your calculator, just sort of leave the pi there and put it back in at the end. Answer ends up being 48.6 times that pi. And so that's the disk method. The rectangle is always sitting right on that axis that we're revolving around, so we just get this nice circular disk. The washer method comes up when your region is not always touching your axis of revolution. So this time I'm going to do y equals x squared, same thing we had before, and y equals square root of x. And so now we've got this region, and this time, to mix things up, I'm going to revolve around a vertical line, and so that means my rectangles have to be perpendicular to that. And so now it's a dy rectangle, which means my equations need to have y in them. And so I'm going to take this, my normal equation, solve for x, and get square root of y, so it's sort of flipped around. Solve this one for x, and I get x equals y squared. And so now when I revolve this rectangle around this line, I've got sort of a big radius and a little radius, and those radii sort of form the outside of a big washer and then the whole of a washer. And we're going to take the one that's farther away, so in this case x equals square root of y. How far is it from that dashed line? Well, it's this distance to the axis, and then all the way to here. And so we're basically taking square root of y and subtracting negative 4. And so that becomes square root of y plus 4. And then the inner radius is this little distance between the inner edge of that rectangle and the y-axis. So that's y squared. And then we still have to go that extra 4. And so this is sort of a common mistake. People forget about the negative 4. This would be the formula if I was just revolving around the y-axis itself. But we want to go all the way over to negative 4. And so my outer radius is square root of y plus 4. I square that, and then I square that inner radius separately. And so it's always those two separate volume calculations. So you're squaring two things and then subtracting. And I just put the pi out in front, so I can just clean that up at the end. This one, again, technically is possible to do by hand, but you're not going to want to do it by hand. You would just use Math 9 on your calculator to kick out that answer. So disk and washer method. Washers when the rectangle is not touching the axis of revolution. Just make sure those rectangles are always perpendicular to the thing that you are revolving around.